Relativity Races, explaining Einstein's relativity by using the example of a car race. In 1905, Einstein made an outlandish claim about light that turned out to be true and that led to his special theory of relativity. My wording of his claim would go something like this: light moves 670 million miles an hour faster than anything else, no matter what the speed of that anything else is. Now it takes some mental effort to truly understand how outrageous that claim was and what the implications of it are. Countless books and videos have been published to help people work through that required mental effort. I think I have an approach to the topic somewhat different from most that I've read or seen, so I'll go ahead and add my own contribution to that library here. And I'll use the example of a car race to help explain Einstein's claim about light and relativity. The race is along a straight course 60 miles long. A bank of bleachers filled with animated car racing fans sits near the finish line, along with a racing judge who will validate the results. 2 races are scheduled for the day, a morning race and an afternoon race. The race officials have created an entry form which each competitor must fill out in order to be entered into a race. The form is quite simple, asking only for the racer's name and the speed of the entrant's car. For in this race, each car travels at a fixed, predetermined speed. Yeah, I know it sort of takes the suspense out of the race, but that seems to be how this community likes it. 3 contenders have submitted entry forms for the morning race. They are Mr. Slowpoke, whose car is blue and goes 30 miles an hour, Mr. Cruise, whose car is red and goes 60 miles an hour, and Mr. Speedy, whose car is green and goes 90 miles an hour. So as suggested, the race results can easily be predicted in advance, with Mr. Speedy the clear winner and with Mr. Cruise and Mr. Slowpoke finishing second and third respectively. Still, the avid racing fans enjoy the race very much, perhaps for the opportunity to do the simple math involved in predicting the outcome. That math uses this formula, which is probably fairly well known and obvious to most people. It states that speed is calculated by dividing distance traveled by the time it took to go that distance. That same formula can actually be written in 3 different ways depending on what we know and what we want to find out. In its original form shown here, we know how far the racers went and how long it took them, and we want to know how fast they went. If we know how fast they went and how many hours they went at that speed, we can use the second formula, just a simple rearrangement of the original, to calculate the distance they covered in that time. But in our case here, what we know in advance is the distance, 60 miles, and the speed, 30, 60, or 90 miles an hour. What we want to know is how long it takes each racer to cross the finish line. A second rearrangement of the formula gives us this version, which gives us time in terms of distance and speed, just what we need. So, using that formula, we find that Mr. Speedy will cross the finish line in 2/3 of an hour, or 40 minutes. Mr. Cruise will arrive after 1 hour, and Mr. Slowpoke will take 2 full hours to complete the race. The judge at the finish line therefore gives the race results as shown here. And that judge has used the original version of the formula in filling out the last column of the results. He knows the race distance is 60 miles, and he knows how long each racer took to complete the race. The judge can then use the formula to calculate the actual speed of each racer. Of course, in all cases, this gives the same speed that we knew all along based on the racers' stated speed on their entry forms. For the afternoon running of the race, the racing officials found the same 3 entry forms as for the first race, but also a 4th entry form from a Mr. Lightning who would drive a yellow car. On his entry form, Mr. Lightning stated that his car's speed was 60 miles an hour faster, which confused the officials. They asked him, 60 miles an hour faster than who? Well, Mr. Lightning responded, 60 miles an hour faster than everyone. The officials were still confused, but the other contestants have different speeds. You can't be 60 miles an hour faster than each of them. That would be physical nonsense. Please, just tell us your speed. But Mr. Lightning was firm. I don't really have an absolute speed. I am simply 60 miles an hour faster than anyone, including you and the judge at the finish line. I am 60 miles an hour faster than anyone. I understand that it sounds like nonsense, but it's the fact nonetheless. Well, the officials were highly skeptical, but race time was fast approaching, and they agreed to accept the entry and allow the race to proceed with all 4 racers. It's our job now to try to predict how the race goes, who wins, what the different finish times and speeds are, and so forth. We will suppress our skepticism and assume that Mr. Lightning's claim about his car are accurate and see where it takes us. So let's start with the question of who wins the race. Now this one is simple. Mr. Lightning's car goes faster than every one of the other cars, or so he claims, so it clearly wins the race. But when will he cross the finish line? It seems like this should be an equally simple question. We simply need to know his speed. Mr. Lightning claimed that he did not have a true speed, but surely he does. Let's try and decide what it is. He is 60 miles an hour faster than Mr. Slowpoke, who races at 30 miles an hour. So we sort of figure that Mr. Lightning's car must go at maybe 90 miles an hour. But he's also 60 miles an hour faster than Mr. Cruz, so his speed, well, I guess must be 120 miles an hour. And he's also 60 miles an hour faster than Mr. Speedy, or 90 plus 60, or 150 miles an hour. And finally, he's 60 miles an hour faster than the judge sitting by the finish line, or, since the judge isn't moving at all, 60 miles an hour. So we have 4 choices for a speed for Mr. Lightning: 60, 90, 120, or 150 miles an hour. We need to pick one. He can't be going at all 4 speeds at the same time, we figure. Which to choose? I guess we will value the racing judge's opinion the highest. The racing judge will see Mr. Lightning cross the finish line at 60 miles an hour, as will all of the delirious fans in the bleachers. So using 60 miles an hour as Mr. Lightning's speed, and using our formula for time, we calculate that Mr. Lightning will cross the finish line 1 hour after the race begins. Since Mr. Lightning wins the race, the other 3 racers must therefore take more than 1 hour to cross the finish line. How much more than 1 hour? That's difficult to say at this time. Remember that in the morning run of the race, Mr. Speedy finished the race in 40 minutes. In the afternoon race, Mr. Speedy is riding the same car and presumably at the same speed, but now it takes him more than an hour to finish the race. Strange things are clearly going on, and we can tell right away that our old formulas, and indeed our entire old way of thinking, is not going to give us the answer. Now, of course, no car can do what Mr. Lightning claimed his car could do. But Einstein's claim about light was quite similar and equally nonsensical and equally problematic. As stated at the beginning of this session, Einstein claimed that light moves 670 million miles an hour faster than anything else, no matter what the speed of that anything else is. This is just like the claim made by Mr. Lightning about his car, except the speed involved is about 100 million times faster. Einstein's special theory of relativity is Einstein's working out of new, more complicated formulas to replace the old simple speed formulas that we've used so far. The old formulas are actually still quite useful, as long as speeds involved do not exceed a few dozens of millions of miles an hour. The old formulas work wonderfully with absolutely no discernible error or difference. But when speeds get above 100 million miles an hour or so, the old formulas start to become less accurate, and we need to use Einstein's new formulas. The new formulas, whether resulting from Einstein's claim about the speed of light or Mr. Lightning's claim about the speed of his car, have the following implications. 1. No object can travel faster than the speed of that special object, light or Mr. Lightning's car. This is sort of obvious given the claim being made that the special object travels faster than any other object, but still the concept is hard enough to grasp that even today people are trying to find loopholes and can't quite seem to grasp the finality of that speed limit. The second implication is that if you're moving relative to another person or object, your clock will not agree with the clock of the other person. Different perspectives will time events differently. This is commonly known as time dilation. We'll talk about that more later. And then third implication is that if you're moving relative to another person or object, your ruler will not agree with the ruler or measurement system of the other person or object. Different perspectives will measure distances differently, an effect known as length contraction. These last 2 implications are probably quite strange sounding, and it will help us in understanding them if we return to our car race. The judge at the finish line gave the race results as shown here. I've used Einstein's new, more complicated formulas in giving these results. and I won't burden you with the equations, so you'll have to trust me that I did the math correctly. But the results seem reasonable if you overlook the fundamental unreasonableness of the basic situation. But at least the races are in the proper sequence, and the times, given that Mr. Lightning finished in 1 hour or 60 minutes, all seem like they might follow from that starting basis. The results show that each of the finishers after Mr. Lightning actually ran the race slower than they had stated on their entry form. But, and this is important, that is from the perspective of the racing judge, or anyone else standing firmly on the ground during the race. Mr. Speedy, however, would have seen things differently from his perspective. As he zipped down the racetrack, he would have counted, as did all of the racers, 60 mile markers passing by on his journey. And his own clock would have recorded that it took him 40 minutes to pass those 60 mile markers. So from Mr. Speedy's perspective, he indeed did achieve his stated speed of 90 miles an hour. Remember implication number 2, or time dilation? It states that clocks will run at different speeds when people are moving at different speeds. That is why Mr. Speedy's watch read 40 minutes, while the race timekeeper's clock said 72 minutes had elapsed when Mr. Speedy crossed the finish line. But doesn't that violate implication number 1, that nothing can go faster than the special speed, or 60 miles an hour in this case? How could Mr. Speedy break that speed limit, which we stated earlier simply cannot be broken? Now that has to do with implication number 3, or length contraction. Mr. Speedy placed too much trust in the track mile markers. Since he was moving, the distance between mile markers was no longer 1 mile from his perspective. That distance had shrunk down to 0.55 miles. If he had pulled out his handy-dandy mile-long measuring stick during the race, he would have found that it would reach from, say, mile marker 20, almost all the way to mile marker 22. The entire race course was not 60 miles, but actually 33.3 miles from his perspective. And from his perspective, his true speed was not 90 miles an hour, but 50 miles an hour, exactly what the racing judge had ruled. In the same way, Mr. Cruz and Mr. Slowpoke would also initially see things differently from how the racing judge had published the results, but upon taking into account the time dilation and the length contractions that would have occurred within their perspectives at their respective speeds, they would have had to conclude that they agreed with the speeds that the racing judge had listed for them as well. And so in conclusion, we can say, 1. Einstein's initial claim about light seems to be nonsense to our common sense, but it has been shown to be valid. 2. This means that our current common sense intuitions about reality must be wrong, at least when things move at speeds approaching the speed of light. 3. Einstein realized that he would need to squeeze space here and stretch time there in order to make things right again. Our intuition about the rigid, rectangular nature of space and time must be abandoned. 4. Each traveler in this new reality also has a unique perspective. Time and distance measurements will differ from perspective to perspective. And 5. The new reality is so strange and counter to our everyday experience so as to be almost unimaginable. Thank you.